Welcome back, students. So this is the Bayes theorem on inverse probability. The statement is this way, that there are multiple events from A1 to AN defined on the same sample space. Now if you consider this as a sample space, these are the multiple events defined on the same sample space, and H is one arbitrary event defined on S such that P of H is not equal to 0. So H is also another arbitrary event in the same sample space, and that its probability is not 0. That means there is a chance, there is a possibility that event H is going to happen. Then probability of any event A among A1, A2, A3, among A1 to AN. So the probability of event say A3, given that H, okay, so H is one arbitrary event. So the probability of A3 given that H is given in this way. So now this is the probability of H given A3, you can say, and into probability of A3 divided by all the events in the same way, that is A1, A2, A3 and so on. So this is how the probability is given. Now it is a similar form of conditional probability, but in conditional probability we had only two values, that is probability of event A, B together and probability of B. Now in this case, probability of along with A, we will have probability of A, probability of A1, probability of A2, A3, so on, and then also their joint probabilities. So when we have this multiple, I mean if it is expanded in this way, then we can apply the Bayes theorem. Okay, so now just look at the formula. We are going to expand the same formula to solve this example. Now example is, suppose 5 men out of 100 and 25 women out of 1000 are color blind. Okay, then okay, so now color blind in the sense those who cannot minutely differentiate between colors. So there are 5 men out of every 100 and 25 women out of every 1000, they are color blind. A color blind person is chosen. Okay, so it's a probability known. A color blind person is chosen. What is the probability that the person is male? Okay, so now we need to find the probability of person is male given that the person is blind, the color blind, you can say. So basically we have three types of events here. Event M is person is male. Then event F is denoted as person is female, and then event C is like person is color blind. So these are the three things given. Okay, so now we don't know the probability of person is male alone, or we also don't know the probability of person is female alone. We know the probability that 5 men out of 100 and 25 women out of 1000 are colorblind. Okay, so then how will you write the given things? So now total number of men plus women, it is not given. So then here we'll be assuming that alone probability, that is probability of choosing male and probability of choosing female, both of them, let's say it is 0.5, or you can say it is 1/2. Now what is the probability that person is male? So we need to find the probability of person is male when it is colorblind. But we know the 5 men out of 100 and 25 out of 1000 are colorblind. Now what are these values? 5 out of 100 and 25 out of 1000. So 5 out of 100, this is the value of, or you can say the probability of men who is colorblind. Okay, so it's a colorblind person 5 out of 100, and we know that 5 out of 100 it's a male, so we'll be writing it this way: probability of colorblind person who is male is given by 5 out of 100. So then this is written as, you can write it as 0.05. Similarly, probability of colorblind who is woman, or you can say female, is 25 by 1000. So it is 0.025. Okay, let me just check. Yes, so it is 0.025 is the probability of a colorblind person who is female, and this is the probability of colorblind person who is male. So these two values are given. Alright, now next we need to find the probability that the person is male and given that person is colorblind. Okay, what is the probability? Okay, a colorblind person is chosen. What is the probability that the person is male? Okay, so colorblind person we are choosing, and we need to find the probability that person is being male. Okay, so then what we need to find is, we need to find the probability of male, okay, or you can say probability of being male where we have chosen the colorblind person. This is what we need to calculate. So probability of a male who is probability of colorblind person who is going to be male. So that is what we need to find out. Now you can see probability of C slash M and C slash F we have, but we need to calculate the probability of M slash C. Now here we need to apply this Bayes theorem. Now this is the formula we are going to use, so that AI, A1, A2, A3 are our nothing but the M and F, okay, the other events, and H, the arbitrary event, is here the probability of being colorblind. So now M and F are our A1, A2. So this is our A1, A2. Now as per this formula, we have only two such possibilities, that is A1 and A2. We can have 3 or 4, not an issue. Then colorblind is our nothing but probability, the event H. Now if you go this way, what you should substitute here? Probability of H given A. So here H is C, so we need to substitute here probability of C given person is male into probability of male. Okay, using the same formula, H is our colorblind and A is our M and F. But here, as it is MC, we need to substitute the just opposite of it into the numerator, and then denominator we will have here only two terms because we have A1, A2, that is M and F. So same term we will copy here, that is probability of C given person is male into probability of being male plus probability of colorblind person given female into probability of person female. Okay, so these are the given, this is how we will substitute. Now the probability of C by M is given by 0.05 and probability of being male is 0.5. Okay, now same term will be substituting in the denominator, 0.05 into 0.5 plus probability of colorblind who is female is 0.025 and probability of being female is also 0.5. Okay, then so what do you calculate here? So the final probability what we have calculated is 0.66. So there are 66% of chances when we choose a colorblind person, then there are 66% of chances that person is male. This is the meaning of this entire calculation. So hope you have understood this example. So similar such examples. So students, this is the another problem. So the problem states that there are three machines together produce 9,000 items and each has capacity of producing 4,000 items on it. Probability that item is defective is 1, 2 and 4% for machines A, B, C. Okay, so among the whatever the items they produce, A, B, C, they have defective items and that percentile is 1%, 2% and 4% on the machine A, B, C respectively. On given day, 4,000, 4,000 and 1,000 items were produced on machine A, B, C respectively, and one item is chosen at random and which is found defective. We have to find the probability of whether it is produced by A. What is the probability that that defective item is produced on A? Okay, so now basically there are three machines A, B, C, so you can say events are probability. There are three events basically A, B, C. So now probability that the item is produced on machine A is given by A has produced 4,000 among 9,000, so it is 4 by 9. Probability of B is also 4 by 9 and probability of C where the item is produced on C is 1 by 9. Alright, so what we need to find out, we need to find that whether the item is produced by A and given it is defective. So what we need to find is, it is given it is defective, we need to find the probability that item is produced on A given it is defective. This is what we need to calculate. Alright, so this is what we need to calculate. Okay then, so then what is the probability of defective item which is produced on A? So that we need to write probability of defective item which is produced on A, and there is 1% chance, so you can say 0.01. Okay, then probability of defective or item produced on B is 0.02, and then probability of defective item produced on C is 0.04. This is the given formula. These are the given things. Now what we need to do, we need to apply the Bayes theorem formula on it and we have to solve. So hope you have understood the given things. A, B, C are the events that where item is produced on which machine, and D slash A, D slash B and D slash C are the events where item is defective on A, defective on B and defective on C. Okay. So now what we need to find out is probability of item which is defective and what is the probability that is produced on A. Now by using this theorem, how will you expand this? So how will you write this? Probability that item is produced on A and it is defective. How will you write about this? We have to just reverse this. We need to take the probability of a defective item which is produced on A as the numerator, into the item is produced on A. Okay, so defective item produced on A into item is produced on A. This will be the numerator. And anyways, we are having here three events. So in the denominator, we are going to have three terms. So that is, first term is probability of defective term on machine A into probability of A. Then the second would be probability of defective term item on B into probability of B. And the third, that probability of defective item on C into probability of C. This is how do you expand. So it depends on the number of multiple events you have in the problem. So here we have got three events, so this way we need to expand it. Okay, so now here we can substitute the values of probability of D produced on A is 4 by 9. You can convert it into decimal and substitute, then multiply into 0.01. Same term you'll be writing here, then plus again 4 by 9 into 0.02, that is probability of defective on B, and then the last term would be 1 by 9 into 0.04. So substitute all these values and calculate for this. Let's see how do you how do you get the value for this. So hope you have understood how we have formed the terms in the Bayes theorem, and then you should be also able to put the values into the Bayes theorem and then produce the final answer for it. All right. So the thing is, you need to understand which is the event you should be using for conditional. I mean, which is event A and which is event B, whose probability is asked, which is given. That clarification has to be there. Then only you will be able to substitute values into this. So hope you have understood this example. Few more such examples will solve in the next class on Bayes theorem. Maybe one more example. So the similar examples are also given in the notes. You try to solve on them. Then we'll meet in the next video with new concepts. Till then, take care of yourself and study well. Hello students, hope you are doing well and you are also studying well. So in continuation with probability and Bayes theorem of inverse probability, this is the another example we are going to discuss today. So the example is this way. A plant has 3 machines which altogether produce scratch cards with secret code for winning a gold coin. Everyday production of scratch cards is 2000, 4000 and 5000 on the machines say A, B and C. A random scratch card is chosen and found with secret code. Then which machine has the highest chances of producing the same? Given that 42%, 39% and 32% of them are with secret code produced on machine A, B and C respectively. Okay, so now there are 3 machines A, B, C and each one of them produces 2000, 5000, 4000. Sorry, 2000, 4000, 5000 scratch cards every day, and on machine A 2000 are produced. Out of 2000, it's 42% of 2000 are with secret code. On machine B 39% of 4000 are with machine code, and on machine C 32% of 5000 are with secret code. Then we are choosing a card randomly and that card is found with a the secret code. Then which it would have been produced on which machine? So what is the maximum probability, or you can say what is the highest chance on which machine it is produced? Okay, so indirectly what we need to find, that if the randomly chosen card is found with secret code, what is the probability it is produced on machine A? What is the probability it is produced on machine B? And what is the probability it is produced on machine C? And then among these, which has got the highest one? So which machine has got highest chances to produce the given the randomly selected card which is already with a secret code? That is the direct question. So here we will be applying Bayes theorem, but we will be applying for all, for every machine we have to calculate. So we have to calculate 3 probability values and then compare them, and the highest one we can say, so there are highest chances that this particular scratch card is produced on this particular machine. Now if you look at the percentile, 42% is the highest percentage that is related with machine A, 39 is the second highest and 32 is the least one. But if you look at the total number of scratch cards they produce, that is 2000, 4000, 5000. So the percentile decreases and production increases. So you cannot say that machine A has got the maximum chances. You cannot even say that machine B has got the maximum chances, because their everyday production scale is different and also their percentiles are different. Okay, so now first we'll write down the given things. So as per the things like we require in Bayes theorem, that we need to write. So we can say we have got three events that scratch card is produced on machine A, machine B and machine C. These are the three events. Then scratch card is with secret code produced on machine A, with secret code produced on machine B and machine C. Okay, so these also we can write. So now we'll have events this way. Scratch card is produced on A, machine A, then machine B and C. Okay, so these are the events. So now probability that randomly chosen card is produced on machine A. So we have total production is 4,000, 5,000 plus 2,000, that is 11,000, and 2,000 are from machine A. So this 2,000 divided by 11,000, which gives you 2 by 11, so which is nothing but 0.18. Similarly, we will write the probability of scratch card which is produced on machine B is 4,000 divided by 11,000, which is 4 by 11. Let me take help of calculator. Is 0.36, and probability that it is produced on machine C is 0.45. Okay, so these are the given probabilities we have written. Now, what we need to calculate is the machine on which machine has got the highest chances on which it is produced, which is with secret code. Now the other things, this 42%, 39% and 32% are the given that those are the with secret code and produced on those machines. Now here let me define one more event called as S, which is with scratch card is with secret code. Another event I define with S, which is a scratch card which is found with secret code. So the scratch card which is with secret code and produced on machine A is 0.42 as it's 42% of chances. Then scratch card which is produced on machine B is 0.39, and scratch card which is produced on machine C is with 0.32. Now what we need to calculate is, we need to calculate the probability that it is produced on machine A, which is found with secret code, probability which is found with secret code and produced on machine B, and the probability that it is produced on machine C when it is found with secret code. So these are the things we need to calculate. So in short, we need to calculate the probability that we know it is a secret code, but if it is produced on machine A. Okay, then how will you calculate for this? So just the reverse of this is probability that given it is produced on machine A with secret code, into probability of A. Now we have got total 3 events, so there will be 3 terms in your denominator, that is probability of secret code produced on machine A into probability of A plus probability that it is a secret code produced on machine C into probability it is produced on C. Okay, so now one thing is there. So when you want to find whether it is produced on machine A, then denominator changes this way. Sorry, numerator is with multiplied with probability of A and along with the secret code which is produced on A. If you want to find out the probability whether it is produced on machine B, then numerator changes with the second term, and then the third time it changes with the third term. Okay, so what we need, we are using only these 3 values with different things. We are making one of them as numerator, but we are using only these 3 terms. So now let me first calculate this every term. Now if you expand this similar way, that to find whether it is produced on machine B and which is found with secret code, then the expansion becomes like this. Alright, so this way you will expand them depending on which events value you want to find out, numerator change as per that. So the denominator is same everywhere. So let me just calculate the every term, that is probability of S secret code given that it is from A into probability of A. So probability of secret code given that it is produced on A is 0.42 into probability of A is 0.18. Okay, similarly for probability that it is a secret code with B is 0.39 into probability of B is 0.36. Then Probability that it is secret code with given machine C is 0.32 into probability of C is 0.45. So let me multiply these all. So the first term gives me 0.0756. And the third one gives 0.144. So these are the terms we have calculated. Now we'll substitute them, and then we also need the addition of all these three. So let me just calculate the addition of 0.0756 plus 0.1404 plus 0.144. This gives me 0.36. So the multiplication of first term is 0.0756 divided by 0.36. Then probability that the scratch card which is found with secret code, whether it is produced on machine B, is, now this multiplication is 0.1404 divided by 0.36, which is the summation of all, and if it is produced on machine C, the given scratch code, it is 0.144 divided by 0.36. So the final three probabilities will be getting first one we have got is 0.21. That is, though there are 42% of them, 42% of the items produced on machine A are with secret code, but if we find some scratch card with secret code, there are only 21% of chances that it could have been produced on machine A. Then for machine B, it has got 0.39% of chances. So if you find the scratch card with secret code, then there are 39% of chances that it is produced on machine B. Coincidentally, it is the same number, it is the same percentile which is actually given for the machine B alone. It's the same percentile for the machine A, B, C all together as well. And then for the C, it is 0.36. So there are 36% of chances. If we find a scratch card with secret code, there are 36% of chances that it would have been produced on machine C. Alright, so now it is very much clear that machine B has got machine B has got the maximum chances that it would have produced the scratch card with a secret code. Alright. So now after doing this only you will understand it is not easy to gauge on the given values with their percentile. You have to apply Bayes theorem, apply conditional probability in turn, and then calculate the value in this way. So if it was asked to calculate what is the probability that it is produced on machine A, then we would do only the first substitution and only this calculation. So it is asked which machine has got the highest chance, then you have to check for the every machine. So you have applied Bayes theorem only, but you have applied for all the components. So hope you have understood this example. You have understood how Bayes theorem is applied. You need to understand how to segregate the events and how to consider which one is given and how to put it into the formula. These all things you need to understand to apply Bayes theorem on it. So it can be any number of events. Now here I have got 3 events. You may also get 2 or 4. Depends on the, it differs from one problem to another problem. Anyways, hope you have understood this problem. Try to solve the given problems in the notes applying Bayes theorem as well. So we'll stop here in this video, then we'll start with the new concept in the coming video. So till then, take care of yourself and also study well. Thank you.